Images and double buffering. Buffered images. Buffered images are objects that can store an entire image. So instead of drawing shapes to the screen, we can now go into Paint, draw something, and say, put that on the screen. Buffered images. Here's the imports that we're going to need. Import java.awt.image.bufferedimage. That's where you get the buffered image class. Import with a lowercase I, not an uppercase like it lists there. javax.imagio.imagio. This is what we're going to use for loading images. Creating and loading buffered images. The first step is you create a buffered image for each image you plan to store. And it's pretty easy. Buffered image, variable name. Then when we go to load images, it has to happen in a try and a catch. Sometimes when you're accessing files, maybe the file's not there, or maybe it can't read it properly and your program will crash. So, when reading images, it happens fairly often that there will be an error. Now, we're going to code well, so hopefully that won't happen very often. But Java knows that it's prone to cause errors when you go out and try to open a file. So it makes you do it in a try and catch block. A try says attempt to do some code. For if any reason there is a fail, you'll go to the catch. And it receives exception E, and I always want you to print e.print stack trace. That'll describe information about the error. And how you load an image is, variable name equals imagio.read new file, quote, name of file, quote. And we're going to try to keep the files in the same place that we're keeping our class files. Drawing a buffered image. So there's a command to draw image, just like there is draw rectangle. It's draw image, image, so any type of image. We're going to be using a buffered image. Int x, int y, that's the top left-hand coordinate of it, and then image observer. Don't worry, we don't have to know what an image observer is. We're always going to use null. So image is going to be the buffered image. X is the top left-hand coordinate that we're going to draw the image at. Y is X and Y together produce the top left-hand corner of the image. And O is always going to be null. We don't really use that parameter. We're going to show an example of drawing two different images now. So I'm not going to code this one from scratch. I'm just going to show you what it looks like. So examples. Double buffer, no, we're going to get to that one in a second. Drawing two images. Now let's go back. I made a folder called images. So in the place where my class files are, I have a folder called images, and I have two images. I have a ladder and a floor. If you notice, that one's a GIF, and that one's a GIF. So I'm going back to the code. And we're just going to look at the frame. I don't have a panel because this project is so simple. Let's see, buffered image ladder equals null, buffered image floor equals null. These are variables to store the images. Here's where I try to load them. Floor, read, images/floor.gif. Ladder is going to be imagio.read, images/ladder.gif. And then if it makes it to this point in the try, it says all images were loaded properly. Otherwise, it says error loading images. But I did this way back when, before I know about e.print stack trace. So I'm just going to go ahead and add e.print stack trace. And I need a semicolon apparently. And now my images are loaded and their attributes. So in the paint method, they'll still exist. So we're going to go down to my paint method and look at what the code looks like. I draw a black background. Then I do g.drawImage ladder at 50-50. And I draw a floor image at 150-50. So let's just see what that looks like. I'm not in the main file because I'm not in a project. What's this m equals 3? Hold on, I want to get rid of this m equals 3. Okay. And we get this beautiful screen with two images drawn. That covers that example. Drawing images are pretty easy, and you're probably going to be pretty happy that you no longer have to use draw rect, draw polygon, and all those commands to do cool stuff. Let's go back to our PowerPoint and finish our last section. Screen flickering. When a program appears to flicker program appears to flicker in and out when data on the screen changes. So, cause. For a brief moment of time, your eye will see a blank screen because we're going to erase a screen, and then we're going to draw new images to the screen. During that brief time where you see the image that has the screen that has nothing on it, that's what's going to produce this flicker. I'm going to show you an example of a flickering program now. So let's go look at a flickering program. So I don't actually have one that flickers, but I have one that we fixed that used to flicker. So I'm going to take out all the code that fixed it. So here, oh, I've already taken out the code. Great. So all the code that I used to fix the flickering is gone. So I'm going to show you. Well, let's look at the program first. So the program has a box X and a box Y. And as you move the screen, it changes box X and box Y, just like that example we had earlier. The only difference is at the bottom it also draws some text that says WASD to move the box. So when we run our program, we get this nice pretty message. But notice, as we start moving the box, it produces a flicker because we erase the screen and then redraw it, erase the screen and redraw it. And in between erases, when there's nothing on the screen, you see it for a split second and then everything appears. That's what creates this annoying flicker. So we're going to talk about how to fix this in the next couple of slides, and then I'll go put the code back to the way that it needs to be so it doesn't flicker anymore. Alright, going back to the slides. Alright, how to fix a flickering screen. Create a buffered image named buffer that is the same size as the screen. You can name it anything, but we just like to call it buffer. Okay, an example of doing this would be buffer equals new buffered image. Get width, get height. It would be as wide as the panel, as tall as the panel, and it would be buffered image.type 4-byte ARGB. That means you want 4 bytes of data for each pixel in this image, and it has alpha, which means transparency, blue, green, and red. I don't know why it's not ARGB, but it's ABGR. It's just a little weird. I don't know why they list them in that order. Alright, then in Paint, do the following. Get the graphics from the buffered image. Draw everything to the buffered image graphics. We're going to be drawing not to the screen. We're going to be drawing everything to the image. Finally, draw the buffered image to the screen. So what we're actually doing is we're not drawing on the screen. We're drawing to an image. Once we finish drawing everything we want to the image, then we put that image on the screen, and it all happens so fast you won't see a flicker. Let's see an example of this. So we're going to repair this, which is basically I'm going to uncomment some stuff. So at the top, I need to create a variable, buffer. It equals null. Check. Then I have to this creates a variable. Now I need to create the object that goes in that variable. Look, I set the size, 400 by 400. Now that we know the size, I can say buffer equals new buffered image, get width, which will be 400, get height, which will be 400. And the type is going to be 4-byte ABGR. So it has alpha, red, and green, and blue. Then we go down here to Paint. Our Paint normally, we call it G, we can call it anything, but we have graphics G. So what I'm going to do now is I'm going to say graphics BG equals buffer.getGraphics. We're calling it BG because it's the buffer graphics. It's the graphics of the image we're going to draw to. And then notice we don't say G dot anywhere. We're just saying buffer, please draw some black. Buffer, I want a big rectangle. We go through everything, and everything is BG. Then as a final step at the end, we say now that we're done drawing to that off-screen image, draw that entire image to the screen at 0, 0. And this is double buffering. So here's my program. Notice it no longer flickers. It doesn't go in and out. Because we do all the hard work and we draw to that image. Then we put that image to the screen in one command rather than having the user be able to see the redrawing happening. Alright, and I believe that's it. Alright, later.